Alright folks, today what we're going to do is learn about writing our own functions. At the end of last time you learned a little bit about how to get a random number, and that is something that I want to write a function related to, but I want to get to a few other things first. Largely the first thing that you use functions for is to do some sort of complex computation for you that might take a few lines of code, and so it's nice to be able to modularize or put those lines of code into a small block so that you can come back and assess it later. Well, make sure it's completely working and then come back and use it again later anytime you might need it. One of the go-to functions that I like to use is Factorial. It turns out that Factorial doesn't have a very large range inside the integers because something like 14 factorial is already over 2 billion. But it is a fun function to write. It requires a couple of lines of code in order to write in C++. I don't think it is something that is in CMath, although I have not looked to see if maybe they added it in C++ 11 or something. Probably not, since it has such a narrow range of where it's available. Alright, so there are generally three places involved with functions. One is that you have to write your function prototypes. Your function prototypes always come up here after your pound includes and before your int main. This is a type of forward declaration for your functions. It doesn't exist in all languages. It does exist in C++. You don't have to use function prototypes if you do something different. But I find that learning this step is more beneficial to you than not learning this step, and it actually smooths over some complications later. Technically what these pound includes do is they include a bunch of prototypes, and then the linker links in their definitions later. Okay, well, moving on. So we want to write a factorial. In this case, we're going to write a factorial that is returns an integer. We're going to call this function factorial, and we're going to ask for something like n factorial. So in this case, factorial of n. So this is going to be a function that takes in an integer and spits out an integer. This first int is the return type of the function. That's what's coming out of the function. This second piece is the name of the function, and then this next piece is the parameter list, or the things that the function needs in order to do its computation. In this case, it needs an integer. This name here, n, that I had listed there that I just deleted, is optional. You can put it in the prototype or not. Turns out the compiler tosses that away, but you'll often see prototypes listed with a variable here. If you do put the variable name there, then make sure that when you write your function definition that you name the variable the same thing. Okay, moving on. The second part related to functions is the function definition. Generally, function definitions are going to go after main. You might sometimes see them show up before main. Sometimes they'll show up in other files. For us, we're going to go ahead and throw the prototypes between pound includes and main. We're going to put the definitions after main, and that's going to solve some issues for us. In order to compute a factorial, we first start with a product equal to 1. So if the user gives us a value like n equals 0 or n equals 1, then our product is going to be 1. And then what we need to do is multiply all the numbers from 1 to n together. So what we're going to do is write a while loop that continues as long as n is greater than 0. And we're going to increase our product by multiplying it by n, and then we're going to write a little decrement step here. This decrement step just subtracts 1 from n and stores it inside the variable n. And so what you're seeing is happening here is we're taking a product, multiplying it by n, decrementing n, and that process is going to continue until n is finally 0. When n is finally 0, we can return the product, and that will be the multiple of all the numbers from n to 1. Not including 0, because 0 helped us get out of the loop. So this is one way you could write the factorial function. It does have some optimization, which we're going to come back and look at. But at this point, you can use this function inside this program. You can copy and paste it into other programs in order to get a factorial. So you might do something like say, hey user, give me an n, and then you can read that value in. So like this will be user input. We'll read it in. And then you can read in this factorial, compute this factorial and output it. Factorial of user input. Okay. So what's great about this is that no matter what the n is, this function is going to run and compute something. So if I go ahead and compile this, you see it's complaining about something. Looks like Microsoft Essentials is kind of upset. I ask for an n. If I give it something like 5, you should get a number like 120, so that's right. If If I get it a number like 0, I get a number of 1 because 0 factorial is defined as 1. If I give it negative 235, well, that's kind of an error case that maybe you want to put into your factorial function. Mine computes it as 1. If you give it a number like 14, it computes this number here, which looks like it's 1.2 billion. But 13 looks like it's 1.9 billion. And so you know that there's something wonky going on. And it turns out it blows up kind of our integer bounds here. I also don't like my input function like this, so I'm going to put a little colon and a space there so it looks a little bit better. In any case, you can use this factorial function more than once, which is kind of why it's awesome. You can use it with expressions. So maybe I want the factorial of 3 times 5 divided by 2. Okay, I can use it with an expression. It will still compute this thing. And apparently 3 times 5 divided by 2 gives me a factorial that is 5040. This looks like it's probably going to be factorial of 5040. That doesn't seem right. 3 times 5 is 15 divided by 2 is 7. Oh, okay, maybe that's right. And so you can use this function many, many times. In fact, that's the point of writing these functions. It makes things modular. You can test and make sure the factorial function is right. You can use it as many times in your code as you need to. Anytime you find yourself writing similar code, it means that you probably should be putting that code into a function. So if you say, hey, I feel like I've written this loop to protect user input like 12 times, hey, maybe we should put that in a function. And indeed, that's the second function we're going to write today. But for now, you should see we've got this factorial function written. You can use it in all your programs. You just copy paste this code right here. It's in a small module, so there's no chance of grabbing other code that doesn't belong there. All of these variables are defined inside this function. There's no messiness when you want to try to port this particular function to something else, right? That's the whole point, is you make these things very modular. Factorial has nothing to do with anything else in this program, even if there's crazy calculations in order to get the ends, or even if you do something crazy with the factorial when you're done, like if you're writing a choose program or something like that. So that's the great thing about it. The other thing that's great about it is if you did have to compute these 2 factorials in this program, and you ended up copy pasting some code, and then you later went and you said, hey, you know what, I think there's an inefficiency in this code. I can make this a little bit faster if I write a 1 here instead of a 0. Well, guess what? You can change the code in one spot, and it makes all the code more efficient, not just the one that you fix. Even better, if you find an error, you can fix that error in one location, and it will fix the error inside all your code instead of having to go through and try to dig out, well, how did I compute the factorial this time, or how did I compute it this time? You do it all in one place, you fix that one thing, you get familiar with your own modularity, and you're done. Okay, what's up next? So a lot of times we write some code to protect input, especially integers and things like that, from failures of the user or failures with CN. And so one function that I usually like to write is something like get integer with a range. And the idea there is to allow the user to type in an integer within some minimum and maximum range. And so what I need to pass to this function is a string, which is going to be a prompt for the user, the minimum, which is going to be some integer since I'm asking for integers, and the maximum, which is going to be some integer since I'm asking for integers. What's going to come out of this is some integer that the user input for me. So what I'm going to do inside here is I'm going to write code that looks, my function calls are going to look something like this, where I ask for user input. You know what? Right here's one. Right, if the user typed a string up here for this user input, well, then it would just break. But we know that for the factorial to be useful, the user should be entering values between 0 and 13. So what I can do here instead is I can say user input equals get integer with range, and I'll pass in, I say give me the n for factorial. This is my prompt. I'll pass in the minimum. They're allowed to ask for a factorial of 0. And I'll say pass in the maximum. They're allowed to get values all the way up to 13. And this is inclusive, so 0 and 13 should be allowed, and we can test that in a second. This is the idea behind this function call. Later on, if you needed a different particular integer, you can ask get integer within range, give me an int. Okay, and you can pass whatever your min and max are. One of your first questions might be, well, what if I don't have a minimum, but I have a maximum? Or what if I don't have a maximum, but I have a minimum? You could write two different functions, but inside climits, there are two predefined variables that kind of come from the old C days, int min and int max. Make sure you pound include climit up here, which doesn't look like it's too happy because I forgot my pound include. There you go, climits. Make sure you pound include climits up here in order to make sure you have access to these. You saw that Visual Studio's just picked it up naturally, so that wasn't a problem. So if you did have a minimum or a maximum, but not the other, you could use int min or int max. If you don't have a minimum or a maximum, then you could just write int min and int max for both, right? And then I'll just output what a is here. So how do we write this function? Well, I've already showed you the prototype. It's going to return an integer that the user input. It's going to be passed a string prompt. It's got an integer minimum and an integer max as the first and second parameters. Okay. What are you going to do with this function? You're going to do all the things that you would do to protect user input. So I'm going to output a prompt. I'm going to read in some integer. I need a variable here. I'm going to read in some integer. I am going to make sure that there was no CN failure. I'm going to make sure that the user entered something bigger than the minimum and less than the maximum. And if they had any of those things, then it's a failure. So if CN failed, or the user gave me something less than the minimum, or the user gave me something bigger than the maximum, which are these three steps here, then I've entered a failure state. And basically, what's going on in this failure state is basically I want to re-ask for x again. Say, hey, you did it wrong. Why don't you give me x again? So you could do that as simply as just giving them the prompt again, and then clearing your failure and doing an ignore. If you don't know what these are, you could just use these and know that this clears out if the user tried to type a string or something instead of an integer. But otherwise, go look them up. They're available in the C++ reference, and you can figure out what they do. Clear clears the failure flag, ignore some stuff on the input stream. Then I read in x again. Eventually, hopefully, they type something that makes sense, and I can return x. If you want to make sure that this function can't kind of screw itself by having somebody call it with a bad min and max, you could add an if statement up here saying something like if min is greater than max, then you know you've got problems, because your minimum should never be bigger than your maximum. And in that case, I don't know what you want to do. Report an error and return a minimum. You can also use cerr to report errors, which is probably the better way. That might be a better thing to do. Another thing that I like to do, instead of actually just giving the prompt again, is I like to kind of give them the range so that they have some idea of why things went wrong and what they might do instead. And so I often give the range. Sometimes I'll give an error. Instead of writing the prompt, I'll just say try again or something like that. And that's pretty much it. Let's go ahead and run this and see what this looks like. And you can see my Microsoft Essentials is still pretty upset. It says, give me the n for factorial. So if I type a number like -3, it gets upset, tells me to try again. If I type a number like 15, it gets upset. If I type 0, I get the 1. Here it says give me an int, and I know I can type in any int that I want, and it won't get upset because it's int min to int max. And try this again. User, give me an n, give me the n for factorial. Let's make sure 13 is in our range. That looks okay. Give me an int. That's always going to be okay. It's not much of a test. Like, we should test minimum and maximums and things like that to make sure that this function is actually working the way we want. But the video is getting kind of long. We're at 15 minutes, and I'd like to do just one more thing. The last thing I'd like to do is that we often want to do randomness. There's two types of randomness that I would love to stay in this video, but due to time I'm only going to do one. And so the one is get a random integer. Rand returns some random integer from 0 to int max or something like that. But get a random integer, what my idea behind this is that it will return the next random integer in some range that you give it. So you'll give it the minimum integer that you'll allow and the maximum integer that you'll allow, and get random integer will just return one of those. And so what I'm going to do here is just output this so that you can kind of get a sense. So let's say you wanted the range to be 5 to 7. And let's do this like 5 times, just to get 5 random integers here at the end. Okay, so this idea is, hey, I'm going to roll 5 integers between 5 and 7. So I should get a 5, 6, or a 7. So my function definition, I'm passing in a min and a max. And then you know that rand is what function I need to call. But in order to get this range, I have to do some cool tricks with modulus and whatnot. So first trick, I have to figure out what this range actually is. Well, it turns out the range is max minus min plus 1. So if I pass 5 and 7, there are actually 3 numbers, 5, 6, and 7. 7 minus 5 is 2. I add 1 to get a range of 3. And then I add the minimum. So I get a number between 0, 1, and 2, and then I add 5. So I'm either adding 5 to 0 to get 5, 5 to 1 to get 6, or 5 to 2 to get 7. And then I can return that. And so this little equation right here is not really that bad, but I'd really rather only type it once, make sure it's right once, and then I can just use this nifty function. I'd also like to be able to do the same thing with floats or doubles, but like I said, we're kind of running max on time here, and so I'll kind of move on. Wow, it is really upset. Here we go. So give me the n for factorial. We can look at what 12 is. 12 looks like it's probably fairly reasonable. Give me an integer, that's fine. And here I've rolled 6, 6, 7, 7, 7. If I do this again, I get 5 and 4 sevens. If I do this again, I get 6, 5, 6, 5, 5. So, you know, it's pretty random. One thing that you'll see in a lot of people who use rand is they'll throw an extra rand call up here, because rand based on the number of seconds is the first number that you get is somewhat predictable. It's somewhat in a small range, and so that rand kind of throws out the first number and then instead starts the generation from the second number. Okay, we've done a lot of things. We've written 3 functions: a factorial function, a get an integer with a range function, and a get random integer function. We have a bunch of function calls in here: 2 factorials, 1 get integer with range, another get integer with range. Looks like this prompt can go away, right? This prompt doesn't need to be here. I would probably rather write this like this, clean up the code a little bit, right? A couple factorial calls, a get random integer call, and a loop like this. You're probably going to do other things with it, and that's fine. And then the function definitions. There's a get random integer. It's usually pretty customary to write a description in front of each of your functions, but I wasn't going to have time to do that today. A get integer with range function. Again, look at all of this logic. I only ever want to type that once in my entire programming career and just be done with it. It's going to protect against all the CN failures, minimum maximums, every kind of integer I ever want to get. I'm going to use this function from now on. And then factorial. If I ever need a factorial, guess what? I'll go here and get it. And I'll use my get integer with range if I'm going to ask the user for something, so that I can make sure I don't blow things up for integers. Okay, that's it for this time. That's kind of a quick run through of functions. There are a couple of points that I didn't talk about. Your functions do not have to have arguments. One example of that is rand. Rand doesn't have any arguments. Turns out your functions don't have to return anything either. Those are usually for functions that are doing some other stuff that we're not quite prepared to talk about yet, or functions that are just doing output. So we'll leave those for another time. And I think that is it for today. Goodbye.